Assalamu alaikum. I am Muhammad Ishan Arifin Hussain, and today I have come up with another lecture of embedded systems as usual. In the previous lectures, I have discussed about the actuators which create some effects in the environment, and we have talked about the actuators like LED matrix as well as the motors. I have talked about three different types of motors: normal DC motor, stepper motor, and another one is servo motor. In this lecture, we'll go through the servo motor and its code in the Arduino a bit, as well as the working mechanism of servo motor from a basic level of overview. So let's begin. So what are the servo motors? So servo motors is basically the DC motor itself, which turns on by getting voltage. So like a simple DC motor that we found in the cars that we broke when we were children. Many of us who were interested in breaking things and taking out the motors, we all know what a DC motor looks like. So normal motors, so you give them power, it will run. So that is a DC or AC motor. And servo motor is basically a DC motor with a gearing set. So the gearing set will help the DC motor for controlling its speed, for limiting its position. I mean, in the servo motor, you can turn the servo motor uh, up to any angle as your wish. So a DC motor, if it gets current, it will run, it will start roaming. So that's how the DC motor works. But and when it doesn't get the electricity anymore, it will stop running, it will stop turning. So that is the mechanism of DC motor. But for the servo motor, it is not like that. So servo motor will of course need electricity to turn, but you can turn it on a particular angle, which feature is missing in a particular DC or AC motor. So you cannot turn a DC motor stating a particular angle, such as turn the DC motor to 30-degree. You cannot do that typically in typical way. But for a servo motor, it can be done, and it can be said that let's turn this servo motor 30-degree. So your motor rotor, which rotates, will turn 30-degree, will just turn 30-degree, will go no more, will go no less. But it actually depends, on the efficacy of the servo motor. So the more pricier the motor is, it typically gives the more efficiency or accuracy or precision, that if you tell it to move 30-degree, it will move exactly 30-degree. So more expensive motors tends to be more precise. So for a servo motor to rotate, it has to have some instructions that how much it will rotate. So it has to have an instruction of the angle it will rotate. So it can rotate 180 degree, it can rotate 90 degree, it can rotate even 360 degrees. So there are different types of servo motors. So we can find a servo motor which can rotate from 0 to 90 degree, but those servo motors are also can be found which will turn from 0 to 180 degree, even 0 to 360 degree. So there are different types of servo motors that can be found. So how can they control this rotating? Because I have told you before that it is basically a DC motor. So how can we manage this? How can we manage this angle that this DC motor will accurately rotate for 30-degree? How can it can be managed by the servo motor? So as I have told you before, and you can see here in the slide, that it has a gearing set. So in a typical DC motor, you don't have one. So you have a DC motor, a gearing set, a control circuit, and a position sensor. And combining these four things, it makes the servo motor. All right, so the gear sets, we will not go into the mechanism of the gearing set, but the gear is actually used for controlling the speed. So we know when you are driving a car, there is the gear set, the gear of the car that controls the speed, and using the gear you can put the car speed to the highest level, and you can control the speed of the car by using the gear set. And if your car suppose is a manual car, then you can change the gear by using the class of the car, the class pedal. You can change the gear to control the speed limit of the car. So by using gear set, you are controlling the speed of the rotation. And in a typical DC motor you don't have a gear set, but in a servo motor you do have a gear set, and you have a controlling circuit here in order to control the motion of the rotor of the rotating device, or the rotating hardware, which is called rotor. So a controlling circuit is used to control the rotor, as well as you have a position sensors which gives the feedback of the current position, that now the current rotor is on the 30 degree. If you have this feedback, then you can tell the rotor to move another 30 degree and go to 60 degree total. So a position sensor is needed for knowing the current position of the servo motor, so that you can then turn the servo motor to another particular angle. So let's see important. um, okay, this is a servo motor. We'll get back to this, but let's see that this is the motor. So the position encoder, so motor rotates to a certain level, then the position encoder gets the position of the current rotation, and then it gives the feedback. It gives the feedback to the motor. So and the rotation signal will go as the PWM signal, pulse width modulation signal. So for rotating the servo motor, you will give a PWM signal, pulse width modulation signal. We have learned about the PWM in some previous lectures. So as you can understand, for rotating, you are giving the command to the motor, using the current position feedback. That suppose the currently the servo motor, currently suppose it is on, suppose it is okay, so suppose it is on 90 degrees, so it is the current position of the motor. So you are getting the feedback here. Then suppose you can tell it, you can give command a PWM signal to the motor to rotate again 90 degree. Then this the rotor of the motor will go from 90 degree to another 90 degree, which will make 180 degree of total rotation of the motor. So you can control the angle of the rotation using this position encoder and using this system. So this is a typical picture of a typical servo motor. Here you can see the rotors. So this is the rotor, and it actually moves. So it can move to any angle. It can move clockwise or it can move counterclockwise. And this motor have actually, the cable has 3 pins. So one pin is, the red one is typically used for the VCC. So you have to give power to the motor to rotate, so this needs the VCC, the voltage, in order to rotate. And of course, for completing the circuitry, you need to have a ground. So the brown cable goes for the ground. So you can connect the VCC to the 5 volt of your Arduino, as well as ground to the ground pin of the Arduino, GND pin of the Arduino, so that the motor can rotate. And there the yellow cable is used for the signal, as you have seen in the diagram here. A signal goes to the motor. So the signal pin, this is the signal pin which will go which will take signal from the Arduino or any kind of microcontroller, and the signal will be that rotate 30 degree, rotate 60 degree. The signal will be like this. So this cable is used for taking the signals from the Arduino or any kind of microcontroller, and then give it back to the motor for rotating. So these three pins are used. So let's see the implementation of the servo motor using Tinkercad. Okay, here we can see 4 separate servo motors are connected with our Arduino, and we can see that they're all getting their power, which is not a good idea in real device. So you should not power your servo motors from your Arduino. You should use external power supplies like a battery for powering your servo motors. You should not use your main Arduino board to give power supply to the servo motors. This is not a good idea. It won't be able to do that, and your Arduino will get some damage for it. So you should not do that. But this is a simulator, you can do anything with this. So we are giving the power, so 5 volts to the servo motor using this 5 volt port of the 5 volt pin of the Arduino, as well as we are grounding this 4 servo motor using the ground pin. All right, so take a look at this, the signal pin here. The blue ones are the signal pins. So the signal pin is connected to GPIOs. So one signal pin is connected to GPIO 3, another one is 5, another one is connected to GPIO 6, another one is connected to GPIO 9. These are the digital input output pins. This can be set as input and as output as well. But for this case, so the signal will be into the servo motors. So let me use the pen attention. Okay, so in this case the signal will be like you're giving the servo motor a signal to rotate 30 degree. So the signal will be from the Arduino to the servo motor. So what do you think? The GPIO number 3 should be an input pin or an output pin? Yes, you're correct. This should be an output pin, as you are giving the output, you're giving a signal to the servo motor, so the pin should be set as an output pin. So same thing goes for these pins as well, for these 3 other servo motors. So let's look at the code, the C code of this. We are using a header file, a servo header file. So this is a default library that is available in the Arduino, and this library has a servo class. So we are making actually 4 objects of servo class: servo 1, servo 2, servo 3, servo 4. So there are 4 objects of servo. Then the setup, in the setup function of Arduino, you are attaching the pins, the signal pins. So this is a library which is a simple library, and it makes your life simple. The servo library makes your life simple to operate a servo motor in Arduino. So you don't need to know anything at all, anything about the circuitry or anything. You just need to know about the signal pins of the servo motor, and then boom, using this library you can easily code for the servo motor. So this servo class has a method named attach. So you are attaching for like you have made 4 objects of this class, so servo1, servo2, servo3, servo4. So in the setup function you are attaching, you're calling the attach function, attach method for 4 of the objects, so servo1, servo2, servo3, servo4. So you are attaching them. So this attach method actually fixes the signal pin for the servo motor. So number 3 pin is attached for servo 1. So then we can refer this particular servo motor as our servo 1 object. So this is the servo 1. Then number 5 pin is attached with this. So this is the servo 2, servo 3, servo 4. So we have attached this, so we can do anything. So if we if we put the servo in the number 2 GPIO pin, then we can attach the number 2 GPIO pin here in order to connect with the servo signal pin. All right, so these 3 pins of the servo motor, as you have seen in the previous diagram, one is used for the VCC. So red one is getting power 5 volt from the Arduino. The black one is the ground pin, it is grounded in the Arduino, and the middle one is the signal pin, which is getting the signal from the digital IO pin of the servo motor. All right, so here you can see that in the loop you are looping through 0 to 180 degrees. So the servo class has another method named write. So we have seen a method named attach, and we have seen another method named write, which used for writing the angle. So which used for sending the signal to the servo motor that please rotate for 1 degree, please rotate for another degree, please rotate for 10 degree. So here you are giving the signal to the servo motor for rotating first 0 degree. So every servo will rotate first in the first rotation 0 degree, then 1 degree. So the loop will rotate. So it will go from, it will increment from 0, then 1, then 2, then 3 to 180 degrees. So the servos will rotate from 0 degree to 180 degree, and then we have another loop. Then the servo will rotate from 180 degree to 0 degree. So if one goes from clockwise to if one rotates from clockwise for another loop, it will rotate anti-clockwise. All right, so in the meantime we can see the delay. So after each rotation, so 4 servo motors rotate for 0 degree, then 1 degree, then 2 degree. After each rotation we will see a delay of 10 milliseconds. So a small delay is there for the 2 of the loops. Let's start the simulation here. We can see the servos are rotating. So it first rotate the clockwise for 0 to 180 degree, then 180 to 0 degree. So this is 0 to 0 to 180 degree, then 180 to 0 degree, 0 to 180 degree, 180 to 0 degree. So that's like it. Let's make the let's stop the simulation and make the delay a bit more. So 1/10 of a second. Let's make the delay a bit more. So now we should start the simulation. It will rotate slowly, because we have made each rotation a bit delayed, because each of the rotation then will take place for a delay of 100 millisecond. Okay, okay, let's increase the increment. Stop simulating. আমরা এখন রোটেশনের এটা ইনক্রিমেন্ট করে দেই। এটা করব হচ্ছে i+10, অর্থাৎ 10 ডিগ্রি করে আমি ঘোরাতে যাচ্ছি এখন প্রত্যেকটা স্টেপে 10। আমি জাস্ট লুপ দিয়ে দেখাচ্ছি, কারণ হচ্ছে প্রত্যেকটা যাতে বোঝা যায়। তো আমরা কিন্তু এমনি জাস্ট সার্ভো 1 ডট রাইট দিয়ে যদি আমি 90 ডিগ্রি দেই, ওটা কিন্তু 90 ডিগ্রি ঘুরবে। এখন লুপ দিয়ে জাস্ট পুরাটা দেখাচ্ছি আর কি ফর দ্য কনভিনিয়েন্স। i-10, তো এখন 10 ডিগ্রি করে বাড়বে, 10 ডিগ্রি করে কমবে, এবং প্রত্যেকটা বাড়া কমার আগে 1000 অর্থাৎ 1 সেকেন্ড ডিলে থাকবে। এখন আমরা একটু ভালোভাবে বুঝবো ব্যাপারটা। ওকে, একটু 10 ডিগ্রি 1 সেকেন্ড করে, এই যে 1 সেকেন্ড পর ঘুরছে, এখন 1 সেকেন্ড পর ঘুরছে। সো ইট উইল গো টু 180 ডিগ্রি ইভেন্চুয়ালি এন্ড দেন টার্ন ব্যাক ফ্রম দ্য 180 ডিগ্রি এগেইন। সো ঘুরছে। আমরা দেখতে পাচ্ছি যে এখানে আসলে 180 ডিগ্রি হবে। এই যে 180 ডিগ্রি থেকে আবার এই যে এই লুপটার কাজ এখন শুরু হচ্ছে। মাইনাস 10 করে কমছে, 10 ডিগ্রি করে কমছে, 180 ডিগ্রি থেকে 0 ডিগ্রির দিকে যাচ্ছে এবং প্রত্যেকটা রোটেশনের প্রত্যেকটা সিগন্যাল যাচ্ছে, কিন্তু এই যে ফর লুপের প্রত্যেকটা লুপ একবার করে ইনক্রিমেন্ট হওয়ার আগে ডিলে হচ্ছে কত? 1 সেকেন্ড। এইজন্য আমরা দেখতে পাচ্ছি 1 সেকেন্ড পর রোটেশনটা হচ্ছে। সো all right, I guess that is it for today. Let's meet in the question answer session. Till then, happy servo rotating. So you should try this servo rotation, and I guess you all have bought the hardware, Arduino hardware in your homes. Please try this code in your hardware. It will be exciting, it will be fun. So I hope you all are enjoying this embedded system course. Till the next class, Allah Hafiz, be well, be safe in this pandemic.